Okay, year nines, somebody's asked me about the trigonometry, so I thought I'd make a video for everybody if you want to watch it. So we've got 1, 2, 3, 4 questions with right-angled triangles. You'll need your calculator handy, and it needs to be in degrees mode, so it needs to have a little D there or a deg on the screen, otherwise you can't do these. Two of the questions are non-calculator, and it's about the wording of them. So let's start top left. If you were given this information, whether they draw the diagram or whether they said ABC is a triangle, AC is 9, CB is 4.8, and there is an angle of 90 degrees at B, or angle ABC is 90, this is the diagram you'd get, okay? If the question said, work out the value of sine A, this isn't a calculator question. Sine A uses the ratio of, well, there's angle A. Sine A will be the ratio of this side and this side. Now, this side has a name in a right angle triangle. That's the longest side. That's the hypotenuse. And you'll find your teachers will have been calling this side the opposite. Most of us will have been calling that side the opposite side, the other side from the angle. So that will mean that sine of this angle is 4.8 divided by 9, which is 48 over 90, which is 24 over 45. I'm going to be lazy today. 48 divided by 90, 8/15. That answer there is the value of sine A, okay? Which is a question in its own right sometimes. And can you see how that would be a non-calculator question? If the question said work out what the actual value of A is, you take that, realize that it's a value of sine, and we would write sine minus 1 of that. Now on the calculator, that shares that button. So it's shift sine, and then I can put a fraction on this calculator, 8 over 15, and close it. I could have typed 8 divided by 15 there, I'll get the same answer. And then you see 32.23, that's 2 significant figures, that's 1 significant figure, 32 degrees is what's appropriate for that one. Okay, so this next one then, if we wanted to find angle X here, if that's the question, was finding angle X, so perhaps I should say find, or perhaps calculate is better, because look, I can find X, it's just there. Calculate X. So what information have we been given? We haven't been told the hypotenuse. We've been told the other two sides of the right angled triangle. And you have to find a way of remembering that that means that tangent is the appropriate trig operator. The tangent of X, tan of X, is this side divided by this side. So if the question had said find tan X, give your answer as a fraction, this is the answer. So if the question was work out tan X, that's the answer. If the question was calculate X, we then use, well, if that's tan, we're going to use tan minus 1 of 4 over 7. So we go back to the shift tan 4 divided by, just to show it works with division as well. So this time I've typed it as a division. We're going to get exactly the same answer as by doing it as a fraction. 29.7. 1 sig fig, 1 sig fig. I'm going to call that 30. On the exam, they will tell you the accuracy they want. But if you're in any doubt, write the display and then make a sensible shortening of it. And just to show you I'd have got the same answer, shift tan of 4 over 7, because remember a fraction is a division, 29.7, the same thing. Okay, that was finding an angle using trig. What about finding sides? So I'm going to start the same way, calculate P, which is this side, which is not the hypotenuse. So if it's not the hypotenuse, I'm not going to use sine or cosine, I'm going to use tangent. And you can look back at your notes about how your teachers, if they gave you any mnemonics for deciding the rules. So I'm going to say that tan of this angle is this opposite side divided by the adjacent side, and the order has to be correct. It's got to be that side divided by that side, whether or not what you're finding is that side. So it's always this opposite side divided by the adjacent for tangent, and that rearranges, I can multiply that by 7. Oh, and look, I've also swapped it round. It doesn't matter. If you'd written P equals 7 times tan 70, it's the same thing, isn't it? So what do we type in? 7 times tan 70, close the bracket, 19 degrees. So notice that when I'm finding a side, I'm using tan or sine or cos, but you pick the right one. When I'm finding an angle, I'm finishing with sine minus 1 or tan minus 1 or cos minus 1. These are the inverse functions. So here, calculate t. Well, in this case, that is the hypotenuse, what we're finding. So we're going to use sine or cosine. Which one of the two? We know the opposite side, the side on the opposite side of the triangle from the angle we know. So this is a sine question. So we start with sine of 15 is equal to this side divided by the hypotenuse. That makes it a bit more awkward. What we want to find is in the denominator. So I'm going to put this up to this side. I'm going to cross multiply. I'm going to rearrange the equation. You find a way of remembering the wording which makes that memorable to you. And I'm going to rearrange that further by dividing both sides by the sine 15. Notice the sine 15, that stays as one thing together, okay? I'm just going to shunt the page up a tiny bit so it all appears on the screen and keeps the top bit. How do you type that into the calculator? You type in, we've got lots of choices. You could type in 4 divided by sine 15 and close the bracket. All right, can we see that on the screen? And that would be, oh, fantastic, because 15 is a fancy angle, we get that answer. We'll talk about that later in year 11, I think. Instead, I'm going to go 15.45. 1 sig fig, 2 sig fig. I'm going to write that as 15 degrees. Okay? How else could I have written that? Oh, look, it looks like a fraction. If I type that in as a fraction, I'm just going to move the calculator so it's not shining in the glare. If I put 4 in the numerator and sine 15 in the denominator, closing that bracket, I get the same answer. Okay? Right then, that's a very quick look at the trigonometry. Things you may now want to look up in the notes your teachers gave you. Some of your teachers would have mentioned that mnemonic, or were a way of remembering when you use sine, when you use tan, and when you use cosine. if in this question here, I told you this side to find that one, it would have been a cosine question, but the method doesn't change. You might want to as well revise. The technique that goes with right angle triangles is Pythagoras. So if you see a right angle triangle in a question, it'll either be trigonometry or Pythagoras. How would I advise you start? Always draw and label a diagram. Okay? And then if in doubt, write that, decide what you know. Okay then, I'm going to stop there. If you've got any questions,